Everyone, welcome to the DevStandup. Today, our guest is Lavanya Siliveri, a principal cloud architect at Oracle based in Sydney. She specializes in OCI, integration, and cloud native development, and is also an active technical writer on Medium. Today, she will be talking about how to secure orchestrating heavy workloads with Oracle Integration and Kubernetes, and go through our Medium blog. So without further ado, let's get started. So Lavana, the stage is yours.
Thank you. Hello, everyone. As Atikin mentioned, I've been working with Oracle Cloud for quite some time now, almost 6 years now. I've been building solutions for customers, and as part of my solution thing and my work, I come across certain problems or certain issues that the customers are facing. I build the solutions for them. And I also write a blog on Medium where I document the solutions which are generic in nature so that others can also benefit from that. So today, the topic that I'm presenting is about how we can leverage the capabilities of Oracle Cloud Integration combined with cloud native offerings, that is Oracle Kubernetes engine and orchestration engine and OCI. So usually my approach to my blogs is like I see something on the internet or in LinkedIn, somebody posts a solution or a question or some suggestion that they make, and I think like how we can leverage that to make a better way of doing things. Or it also sometimes gives me ideas on how we can build something which could possibly solve an issue or a problem that might occur because of this. So as a matter of fact, this is the LinkedIn post that I was scrolling through, and I saw this, which is talking about the patterns and anti-patterns that we should not be using while building integrations in Oracle Integration Cloud. So here, as you can see, the LinkedIn poster, the author of this post is talking about the anti-pattern, where you should not be using Oracle Integration Cloud to process like thousands of records, because in an ERP kind of situation, in an enterprise business kind of situation, the data is not small. Usually the data runs in thousands of records, and processing them or looping them inside an orchestration layer like OIC or Oracle Integration Cloud is an anti-pattern. So Oracle recommends an approach called FBDI, which is tailor-built for handling such kind of heavy data. So that's a suggestion, or that's a recommendation that Oracle is providing. But the thing is, these kind of the async processors and FBDI kind of generation of files, it's very specific to Oracle realm, and within the Oracle systems, it works perfectly fine. But what if the end system or the target system where we are supposed to store this data is not in the Oracle ecosystem and not in the Oracle realm, like a Snowflake or a Salesforce, or rather you have to deal with data which is not in a format, then it should be formatted into FBDI, and then you need to process that data. So in such situations, I was thinking, how do we approach this? Like how well we can build this without having to overload the systems on OIC or having to write custom code to build the whole process. So the immediate thing that came to my mind was to use Oracle functions, because functions is something that are like trigger and leave, like a lambda. You call in AWS, it's called lambda. In OCI, we call them functions, and Azure and GCP also calls them functions, or the serverless. So serverless was the first choice that came to my mind, because it gives you the flexibility to have the code executed for the time or the process that you need, and you do not have to build heavy logic into it. You do not have to maintain any infrastructure for it. because it's a fire and forget kind of thing. Like you trigger the function, you execute it, and you're done with it, and you are only charged for the time where you're executing the code. Then it occurred to me, within OCI, the functions have certain limitations in terms of the execution time and in terms of the memory and CPU that we might require when we are dealing with, let's say, not thousands of records, but tens and thousands of records or millions of records. And there could be certain storage situations where you need more memory, or in memory or temporary memory, where you want to process certain logic before you start processing the records or the files, the actual data that is supposed to be entered into the target system. So it all became the obstacles for me to use OCI functions. So the next best thing that I found, it felt to me like where I can get all this compute logic with all the flexibility in terms of the memory, CPU, storage, and processing, was to use cloud native. So the next was, yes, orchestration, OIC is the best, and processing, cloud native. Because using cloud native or OKE Kubernetes cluster, it gives me all the flexibility to define my own memory, define my own storage and CPU limits using a Docker image. And that's when I started building this solution. So the overall solution is very simple. It's just 3 steps where you receive a file, which could be formatted or in a not unformatted state. And you might have to do some certain logic on that file before you process it and send it to the target system, whether it is an ATP or a database outside Oracle, or a Salesforce, or a Snowflake, or any target system which is not Oracle bound. So the first thing is like basic. I'm using the object storage, the file storage system of Oracle Cloud to store the file. And I'm using Kubernetes job. Like I spin up a job which will create a pod, and inside that pod, it will run the logic that I want it to on the process on the file, and then it finishes the job. It seems pretty simple, but while we are doing this, I wanted to make it completely secure. It's not that you can access the control plane of Kubernetes cluster through the APIs through Oracle Integration Cloud. However, I wanted to make it agnostic to the end user regarding the security system that we use to access the Kubernetes cluster, and how the Kubernetes job accesses the object storage to read the file from the object storage. Usually when we are working with such kind of scenarios, we use the cluster token. The token gives you the access into the Kubernetes system, and Kubernetes pod or instance would like to have access to the object storage system. So when we are building this, developers usually tend to create the configurations inside OIC by copy pasting the token themselves, which the tokens are something when you generate, there is a time to live, or the tokens can expire. So every time the tokens get expired, you will have to access the integration and the connection to update the token data, and then you run it. It becomes like a maintenance kind of issue where the developer or the administrator who is managing this is to be familiar with the Oracle Integration Cloud system, and also updating it the token all the time could pose some security issues. So I wanted to make it as dynamic as I can wherever we can, so that we do not store any of this sensitive data inside the Oracle integration orchestration, and it becomes dynamic in nature, so that developers don't have to keep updating this. So there will be one admin who has access to the Oracle Cloud control plane, and they can use I'm using Oracle Cloud Vault to store the tokens. And using a OCI Vault, what happens is that it encrypts the data and stores inside the vault. So there is no way that you can decrypt in transit when the token is being passed from OIC to the Kubernetes job, or and I'm using workload identity for the pods using the Oracle integration, Oracle Cloud's identity and access management, which will allow the Kubernetes pod to access the object storage using the workload identity. This way, we are isolating the places where we have to provide the necessary configuration or connection security details to these systems so that they can seamlessly talk to each other without knowing the details of the security part. So OIC triggers the Kubernetes job using the cluster URL through a dynamic injection of the access token from the OCI vault, and Kubernetes pod accesses the object storage to read the file using the workload identity. So the steps are pretty straightforward. Like OIC integration is built in such a way that it reads the file's name, which receives the file name in the object storage, and sends the detail in a JSON payload that we are building to the Kubernetes job. And Kubernetes job spins up a pod using the Docker image that we have built for the processing, whatever the processing or the logic that we want the file to go through before it gets stored into the target system. It runs the code there, and then it writes the acknowledgement back to the object storage with the report of either success or failure. So this way, your Oracle integration that you're building, it doesn't have to wait until the job has been completed, because the job could run for more than 5 to 10 minutes, because processing huge workloads has to be done in an async mode. So you're decoupling the execution part also. And while you're decoupling the execution, I'm putting a point where we get an acknowledgement from the Kubernetes job once the job has been completed, either successful or failure. This way, what happens is that it gives you the async execution part, and also gives you the acknowledgement or the update on what has happened to your job. So everything runs in a sequence, but in an async mode. So the first part is pretty straightforward. I'll just go through the integration that we have built for this, but I'll show you the image later. The first thing is that once we have this Kubernetes, first we need to build the job, like create the Docker image part of it. So the first thing to do that is to have a token, and OIC is a service which is outside the Kubernetes job. So it has to access the cluster to create a job for it. For that, I wanted to create a specific access and not give a wider access. And it should only do what it is supposed to do from the security point of view. Initially, me being lazy or to get things done, I created a cluster admin token, which gives you the complete control of the cluster. But instead, we have to always focus on giving the necessary access only to what is required or what is needed, and not give wide level of access to any system that we are working on. So that should be our primary focus when we are building decoupled systems, because any slip up in the security can cause issues later down the line, when with wider access you don't know where the problem has occurred. So we need to always focus on giving the necessary access only, and the first thing should be like a deny all, and start giving access only where and when required. So for that reason, what I did was I created a service account. So for my OIC instance, I created a job, created a role. The role is specific, like the OIC should only create the job, and I created a role binding to bind it to the role that I have built, and a secret, because I wanted to store the token that I'm generating for the access in a secret, so that I can keep the secret content inside my OCI vault. So as you can see, we have multiple ways to generate the token to create the connection. One is to create a short-lived token by using the command kubectl create token. But the problem with this short-lived token is that every time a token gets expired, somebody has to go to the OCI vault secret and update the secret content with the new token. And if just in case, if the token gets expired when you're about to trigger a job, then it will create a problem when it will fail the job, or either the integration will fail if you're not able to access the Kubernetes cluster. So I used a long-lived token for now, using the secret approach. And we are storing this secret inside the OCI vault. So only the administrator of the OCI vault will have access to this token or to update it. And OIC will dynamically extract the token at runtime and inject it into the payload before calling the Kubernetes cluster URL. So basically, this is the connection screen when we are making a connection to the cluster. Here, this is the default cluster URL, and I'm creating it with no security policy. So you do not enter any access tokens or any security related information here on the screen. It's basically just the URL and with no policy. So when you look at the integration as a whole, it's pretty simple with few steps where we are like triggering, fetching the OKE token from the vault. This is the connection to the vault, and we are triggering the job. This is where the async mode ends, where you trigger the job and you wait for the job to complete. So before you invoke the job, you have to configure certain headers inside the connection parameters or the invoke parameters, where we have to dynamically ingest the token into the cluster URL invocation. So here I'm mapping the authorization using the token that I'm fetching from OCI Vault and sending it as authorization parameter in the HTTP headers. So once we have this setup done, we have to prepare the payload for the OKE. So with the necessary information that we are processing on a file that is available in an object storage. So in order to do that, we need to provide a object storage bucket detail, the namespace to access the object storage for the tenancy details, and also the name of the file that we are going to process it. So now the job creator, like OIC, has access to the Kubernetes cluster and it knows the job that needs to be executed. But how does the Kubernetes job or the pod have access to the object storage bucket to access the file, to read it, to stream it, and then process the data on it? So in order to do that, we have to create another service account, which will allow the Kubernetes pod to access the object storage through the workload identity. So I'm creating a dynamic group, which will use the details that I'm providing, where the resource type is a Kubernetes service account, because I do not want to give wider access. I'm only giving to a certain service account here. And I'm also giving the namespace and also the service account name for which we want to provide this access to. And using this dynamic group, I'm using the dynamic group and annotating it to the workload identity inside my Kubernetes cluster, saying that this particular service account in this namespace, the data processing, will be associated with the workload identity. So in this way, we are isolating or giving necessary or required access to a particular pod or a pod that is getting created inside this namespace, and it should be associated with the service account of the name data processing. So this way, other jobs or other pods that get created in the cluster do not have access to this, and it's very specific to that particular pod or job that we are creating. So for the pod to be created from a standard image where I want it to do certain actions on the file, we need to create a Docker file so that it generates an image, a Docker image for the pod to build on. So I created a very simple Python file where I'm just reading the file from the object storage, just running through the records to see what in particular in some chunks, and I'm saying whether the file is empty or does have some value. After processing the number of records, I'm not doing too much logic here. It's just to present like how we can process this. So I'm just doing a row count on the records that are in the file, and I'm generating an image out of it, pushing that image to OCR, and then we are done with this. So now we have OIC set up with the necessary access to trigger the Kubernetes cluster to start a job, and Kubernetes cluster has the necessary image that it needs to create the pod with and to run it when OIC submits the job. But we need to know what kind of details that we have to send from OIC to OKE to create the job based on the information that we are sending. So this is a sample request payload that I'll be using from OIC to the OKE job or to trigger the Kubernetes cluster. Here you can see it's a standard a JSON representation of a YAML file where we are telling the we are giving all the metadata like the namespace and the application name here, and I'm giving the specifications of the service account because I want to create the pod with the service account associated, which will allow it to use the workload identity that I have created to the service account. And I'm giving the image detail because I want to create the pod with the image that I have generated above. And I'm using the image pull secret because it's a private repository. It gives another additional added security. And this OCR secret also is stored as a secret in OCI Vault. So there also there is no entry of data or details from external or for the developers. The next thing is the namespace and the bucket name and the file, the actual file that I want to process. And this is where the storage and memory requirements that I was talking about, which was not possible to customize with the functions, but we can use our resources and limits tags inside the job to define if you want to increase the memory or increase the CPU based on the file sizes that you might be processing. You can always change this dynamically inside the payload before you trigger the job. So this gives you the flexibility to offload the process, offload all the compute, all the logic that you have to do on huge files to Kubernetes from OIC. So OIC or Oracle Integration Cloud is just orchestrating that. It sees that there is a file that has been uploaded and it requires certain processing. You trigger the job and you also provide necessary limits or resources for the pod to process the job. And we map all those respective values using the mapping activity inside OIC, and then upload the file to the OCI bucket, and we trigger the integration with all details. Then we can monitor the cluster to see the job completing. Once the job is completed, we should see the report file, which is an acknowledgement of the processing, whether failure or success, and it gets uploaded back to the object storage bucket using the same workload identity that we have created for the pod to access the file to read and write. Now that we have done this, I'll share my screen to my Visual Studio Code where we can go through the steps and see the whole process in action. So yeah, these are the files that I was showing on the blog. The service account secret, the service account file that I have created, the role for processing the job to create the job. So these are the rules that I have applied, like the resource that I'm providing for this role is only to create, get, list, or delete the jobs. And the role binding, I'm associating this particular role to the service account, which is the OIC orchestrator service account, which gives access to the OIC instance to trigger this job using that cluster URL. So we completed this step where we are creating a service account, a role, and binding that role to the service account. And the secret, which is the token that I will be generating to store in the OCI vault. So in the next step that we will be doing is to create the execution for the workload identity part, which is pretty much the creating the dynamic account and dynamic group and annotating the service account with this workload identity. These are the commands that you run from the terminal. And I'd like to run through this simple processor Python file, which is an excerpt here. So this is the basic simple Python file. I'm trying to get the inputs, the context, which is the namespace and the bucket name and the file that we are going to process. And I'm using the object storage signer using the workload identity to fetch the object or the file from the object storage, and I'm chunking it to just simulate the kind of processing. Here I'm not doing much of processing, it's just going through the records and performing a row count. And once the row count is completed, if it is a success report, I'm uploading it to the bucket. If it is an error, then I'm again uploading a report into with a job failed message. So once I create this Python, I'm generating the Docker file, which is also a very simple Docker file where I'm copying the processor py, the Python file that I've created, and a very simple requirements.txt file, which has the dependencies that I'm supposed to download. Because in my Python, I'm using the OCI library. That's the only thing that I will be I'll be downloading or creating the Docker file to download it as a dependency into the system. So this is pretty much the setup part of it. So how do we trigger this? So from the for the triggering part of it, this is my sample transactions.csv file that I'm sharing, which has a bunch of records that have a list of transactions, around 300 transactions, with some data like I have the amount, I have the currency, the status, and timestamp. And these are records that I want my Python file to process. Sometimes this looks very simple, but usually when you get data in an ERP kind of situation, you have hundreds of columns with thousands and thousands of records. So I have uploaded this to my object storage bucket. This is the bucket that I have uploaded it. You can see this is the testtransactions.csv file that I've uploaded. Now I'll be using this to trigger my integration, this integration with the necessary details, so that it will submit the job. So this is the sample payload. Go to my So these are the previous jobs that have been completed. There are no current jobs that are running. And even in the bucket, we have created the logic actually states that it should create a directory called results, and inside that results directory, the report will be written. So there is no results directory here at this point of time because we haven't executed the job. So I'm using this input to submit the integration, which will trigger the job. I'm going to run this. So you can see that it has triggered my OK job and has completed the integration. We'll switch back to the VS Code to check the jobs. So here you can see there is a running job that has been executed. And I can see that there is a pod that has been created. In the data processing namespace. We have to check in the data processing namespace. So I can see there is a container that is getting created. there's a container that is created and is completed. So job has been completed. The submitted job to process the data is completed. So if we go back to our object storage bucket, we should see a report of the data that has been processed. So go back. We see this result here. Has been created, the report, the JSON file with the output of whether it has been processed or not. So let me download this file. You can see that the file has been processed successfully. I'm just running through the records. So this way you can decouple the flows in async mode and also shift the heavy work or the compute processing from OIC to cloud native and combine these two services from OCI to orchestrate heavy workloads by decoupling the logic. And you do this securely by providing dynamic authentication injection at runtime, and using OCI Vault, you can have secure access to your secrets in an encrypted format. That brings the end to this session. Thank you so much for this opportunity.
Yeah, thank you. I have one question. Well, firstly, it was a very interesting topic. I wasn't aware of the IAM options available on the OCI. I just have one question about are there any built-in functions inside this Oracle integrations, like the builder place, where I can also plug in the IAM generation of other services like the AWS, GCP or something, where my target buckets are, or should those be done in the code, like the Python code that we are running?
Now, OIC comes equipped with a lot of adapters, native adapters, as we call them, which will give you a native integration between services. I will show you. So here you see all these connection parameters that we are looking at. So you can connect to your S3 bucket. You can also connect to your Azure storage. So you do not have to create anything inside your Python. You can create connections to an SFTP server, your Google Cloud Storage, any storage where you want to load the files from. There are hundreds of adapters that are available, which you can see them on the home page of Oracle Integration Cloud. This is the store, the browse store, where you can see pre-built integrations where you do not have to build. Like when I showed my integration, it had step 1, 2, 3, right? Where you are creating a mapper or an invoke or a trigger to the connections or the service that you want to read or write or access data from. Those basic use cases, like most generally or widely used use cases, we have documented them as called recipes. So when you want to do a certain operation, like for example, you have a NetSuite system and you want to build an integration which involves NetSuite and several or some other system along with it, where, for example, here you can see you are automating the lead to cash flow between Salesforce and NetSuite. So this particular flow is pre-built for you, and you can get it without, you can import this integration into your OIC instance without having to write the code from scratch. So once it gets downloaded into my projects, I will show you. So here is one such integration between EBS and the CX system. and the one that we just imported, the NetSuite one. So you can see that it gives you all the default connections that you are supposed to make, and these are all native connections, so that it gives you custom information about how to create the security. What are the details that you need to provide for this to create a secure connection to the NetSuite system? And the integration is pre-downloaded for you, which is configurable again. You can see all these blocks, mappers and invokers are in place, and they are created inside a scope where you have default error handling mechanism for each scope that you generate. So this integrations, which are called the pre-built integrations or recipes, they come with Oracle recommended best practices and error handling and coding practices, which will help you in writing better integrations without having to do everything from scratch. This is a scheduled integration which runs on a schedule, so that's why you have a schedule activity. If you want to make it into a trigger based, you can replace this schedule to become a application based or a trigger based integration also. So these are all configurable like a Lego blocks, which are available for you. Some of them we are shipping them like a generic use cases. We are shipping them out of box, where you developers who are working with OIC can do a minimal work without having to stress on where you want to do everything from scratch. So this helps you in accelerating your development process.
Yeah, awesome. That answers my question quite well. Well, that was it for this today's episode. Thank you very much for joining, Lavanya, and see you guys on the next episode. Bye for now.